All right, everyone, let's start on 6.1. I'm not going to ask you to graph too much because that can be done with your calculator or Desmos browser. It's pretty cool, the website. But I do want you to be able to find amplitude, midline, period, etc. So this is number one in the homework, 6.1. What you're mainly going to need is this PDF that I made you. Let me find it. Here we go. So number one says to find the amplitude and the midline. So amplitude for sine and cosine is just going to be the A, the number in front of sine. Okay, so right there. Doesn't matter what's going on, that's your amplitude. The midline is going to be the D right here. So if there's a constant added to your function plus some D, that's your midline. So in our question, 18 would be our amplitude, right? So it's always the absolute value. Of 18, right? So nothing really changes. This is the amplitude. So if it's negative 18, you would put 18 for amplitude. Now the midline is going to equal to -1. Or what we should say, y equals -1. So that's all you really got to do. Look at the homework here. Midline and here we go. So for this question, y equals 7 and amplitude equals 8. So y equals 7, 8. Ours was y equals -1 and 18. So no big deal. That's number one. Let's do another one. Before we go any further, I want to go talk about what they look like, the original sine and cosine functions. The cosine x is right here. This repeats itself over and over again. At 0, pi over 2, pi, 2 pi. So, or 3 pi over 2 and then 2 pi. Notice how after that full period, right, 0 to 2 pi, it repeats itself. It starts over. Okay, now, as we were talking about earlier with amplitude, if I put a 2 in front of cosine, it's now been scaled by 2. Okay, so the highest point is 2, lowest point is -2. Over here, highest point was 1, lowest point was -1. Okay, so if it's 3, you should be able to guess it should be a triple, right? Same thing for sine. Let's go ahead and put that sine in here. Same deal. The only difference is that it starts at 0 and then repeats at the same place, but starts up, going upward, and then stops here. In one period, it repeats itself 2 pi. If you multiply by 3, then it triples the amplitude. Highest point is going to be 3. Lowest point is -3. Okay, now for period, original cosine, we said, starts over from, or has a period from 0 to 2 pi. If I were to double the number in front of the x, notice how the period it's repeating itself in half the time because it's twice as fast right here compared to this one. This goes from 0 to 2 pi to repeat itself. This repeats in 0 to pi. So the period is shorter because this is 2 times as fast. Okay. Now that's the idea. If you triple it, then it's going to be repeating itself 3 times within 0 to 2 pi instead of twice here. Okay. So let's do another question. Suppose we have 3 pi cosine of negative 8t plus 1. I don't like t's because they look like weird. Let's do 8x. Okay. So here they say, what is, let's be a little more proper. Midline. Amplitude. Now they want the period. So the midline should be just this number, 1. Amplitude is the number in front of the cosine. Absolute value of that number. The same rules apply if it were sine. Sine and cosine have the same rules. Period is going to be 2 pi over, let's see what variable the notes use. If you go to the PDF I sent you, period is the number on the x here. So whatever you factor out here goes down here. So 2 pi over b is what they call it. 2 pi over over b, which is in our case 8. So they take the absolute value. So 2 pi over 8 is going to be pi over 4. Now let's look at our homework. So in their example here, midline is this number, just like we had ours. Amplitude is this number right there. Period is 2 pi divided by 5 right there. And that's it. Okay, so a lot of the homework is going to be similar. So the next one is going to be the same deal. Amplitude is -2. Period will be determined by 2 pi divided by this number right there. Okay. Amplitude is 6. Period will be 2 pi divided by this number. Phase shift, that's new. Our notes say that the phase shift right here is C over B. So you take this number and divide it by B right here. So in our case, let's just go ahead and look at the example, save some time. In our case, for the phase shift, they take the pi over 6 and divide by 7. So that's where this comes from. Pi over 6 divided by 7. So when you divide by 7, it'll end up down here. So here is the phase shift. So nothing crazy. We're just following that printout. Okay. This guy here asks about a vertical translation. Let's look at our notes. It's too far. Okay, here it is. It turns out vertical translation is just another word for the midline, which we've already done. So the k, the number outside plus or minus k, right, is your midline or vertical translation. So in this example, it would be 3, vertical translation. Yeah, 3 right there. See. But yeah, that's pretty much it. It'll just repeat itself over and over again. You just read the book, look at the summary that I gave you of all the properties. Should be good. Let's look at 6.2. Well, let's move on to 6.2. 6.1 is just sine and cosine, find the excuse me, find the amplitude, period, midline, and phase shift. So I was just following that sheet that I gave you. Nothing crazy. There might be some extra things, but as you practice, you'll see what I'm talking about. 6.2 is the same thing, except for tangent, secant, cosecant. So I won't spend too much time on this, but just really quick, let's do a few so you can see the idea. On the first one here, they give us tangent and they tell us what happens if, or can you give us an equation that does all these things? So example 1. The graph of tan x is stretched by a factor of 12, shifted a distance of 8 units to the left, and then reflected, and then translated upward 4. Okay. So we should remember that the amplitude is what creates the stretch, right? All right. All right, so factor of 12 shifted. So y is equal to 12 tangent. Okay, then it says shifted to the left, so it's going to be x plus 8. Because if it's going to the left, then it's going to be opposite, plus 8. If it's going to the right, it'd be minus 8. And I'll show you in a second on the grapher. Then it says shifted upward 4, so that'll be plus 4 out here, because this does the vertical shifting, this does the horizontal shifting, this does the scale. Okay. Now, all of this is stuff you did in college algebra, but let's go ahead and just see it happen on the grapher here. Okay, so y equals 10 is the original. Y equals 12 tan. Well, actually, let's use an easier example first. Use cosine. So y equals cosine, and then you put plus 8. Notice how it has shifted the original, which was at 0. The blue one will now be, this point will be related to, can't really see. Let's do a vertical line at 8 so you can see it. -8. Okay. So this point has now been moved to here. Okay. So this is what the shift does, plus 8. Now, if you do a plus 4 out here, it shifts upward 4. if you put a 12 in front, we said that scales it by 12. So in this question, that's what this is going to, that's what's going to happen to the tangent here. So they wanted something that would shift to the left, so +8. Something that shifted upward 4, so +4. And it's scaled by 12 times 12. So that's all you got to do. So let's look at the question one more time. Stretch by a factor of 12. Shifted a distance to the left 8. So if it was right, you would put -8. Since it's left, you do +8. It's going to be opposite. Reflected across the x-axis. Oh, I forgot about that. Remember back in college algebra, right? If you have a minus in front of your function, it reflects across the x. For example, this is the original example, right? X squared, it's parabola, but if you put a minus on it, we should remember it reflects downward. So I'm going to have to put a minus on my question here. And that's it. That answers number 1. But I just want to walk through how each of these pieces work. Okay. I'll for sure give you something like that on the test. Number 2, ask for the period of the function. So we gotta go look at the notes again. Period of tan, so 6.2 starts right here, is pi over b, where b is a number on the x. So just divide by whatever's on the x. So let's go ahead and look at that example. Oh, let's look at something similar, I guess. So we can look at the steps. So if you see like 2 terms like this, you can't just, I don't know, sometimes you can, but you may have to factor first. You can't just take the x value like we've been doing. So keep in mind that you want to factor whatever these guys have in common. And it turns out it is the one on the x, so it's whatever. So you kind of force the factor. So I don't think it's going to matter for this example. So yeah, just take this number on the x and divide into pi. That'll be the period. Okay, so in this example here, you'd take pi divided by this. So I'll go ahead and write that example. Example 2. Find the period for y equals 4 cosine, or actually cotan, for cotangent (13 pi) over 12x. Can't seem to write in this little spot. Plus 4 pi 13ths. So the period will simply be 2 pi divided by 13 pi over 12. So these pi's will cancel. You'll end up with, let's show the work, 2 pi over 1 times 12 over 13 pi. This is why they cancel. 2 times 12 is 24, so you end up with 24/13 as your period. So you should just put 24/13 in here. Oh man, where did I forget? 13 pi over 12. 24 13s. Oh shoot. Formula says pi, not 2 pi. So that's my mistake. Right. I put a 2 right here. Should be no 2. It's just pi. Which means that this isn't 12. There we go. The thing we checked. Okay. So just follow your notes, graph them on Desmos or your calculator, and you should be good. Phase shift depends on the function you're working on, so refer to the correct one. Okay. If they're working with tangent, we'll go to tangent. If they're doing cosine, we'll look at the cosine properties. Okay. Let's look at this example here. In the notes on the PDF I sent, it says phase shift is equal to C over B. Okay. The period is pi over B for tangent. So you take these guys here, divide C divided by B. So in our example, period is just pi divided by the 9 right here. Right? Nothing crazy. You just take this 9, divide into the pi. Now for phase shift, you take, notice how it was, actually there's a point we got to mention first. Notice how this is minus C and this is positive. So it's going to be opposite. The B is just straight up whatever the B is, but this is opposite. Notice you'll see it on this example here. It's plus 8, so they put a minus. So this is coming from the top part. And then the 9 is just right there. C over B. C is negative, so they use the opposite. If this was a minus 8, you would have a plus 8 here. Okay, that's about it for phase shift. And that goes for sine and cosine as well, just C over B. Okay. Here's more of a conceptual question. I'll let you guys think about that one. But yeah, that's pretty much it. Here you'll have cotan instead of tangent. So just look at the formulas for cotan and tan. But yeah. I think 6.1 and 6.2 are pretty chill. I'm not going to force you to do any crazy graphs. I just want you to be able to, the main idea, right? For 6.1 and 6.2 is, do you know what sine, cosine, tangent, secant, etc., all 6 of them? Do you know what they look like? And do you have like their properties handy that I just gave you? How do you find a period? Well, how do you find an amplitude? How do you find the phase shift, midline, that type of stuff? And that's all in that sheet. Okay, so just practice finding those things and look up what they look like. Okay. Yeah, that's pretty much it. We'll do some examples if you have questions in class on Monday.